Okay, so we've already had a chance to look at exothermic and endothermic reactions using the energy graphs or diagrams. Now what we're going to do is going to do the same thing, looking at a reaction if it's exo or endothermic. But now we're going to use the chemical equations.
Yep. So we're going to actually look at an equation and see where all the numbers fall, right?
Right. And if you notice with this chemical equation, we actually have an energy value in there. And so what we want to do is we want to look and see, is the energy, that's this part right here, if it is a product or a reactant.
Okay, well, I know products are being produced, so they are on the produced side, things being created and made, so they're on your right side.
Yeah.
And our reactants go in because they're what's actually reacting, so they're coming in from the left. Okay, so this particular number or energy value was on our product side.
Right, so if it's on the product side, that means the above reaction is exothermic. So energy was released.
Right. Makes sense to me.
If we have it, now we've switched sides, now it's on the reactant side.
We said that was reactant side, so therefore this one is endothermic.
Yeah.
So the energy went in.
Yeah.
Okay.
Those are pretty straightforward. Now we can kind of...
Now I guess we should point out though that while they were looking at the graphs, those values were positive and negative.
Right.
And on here they both look positive. Right?
Right.
But that would be because even though it was losing it on the product side, so it would have been a negative.
Right.
Because it lost it, but it lost it as a product, so it was kind of added on as far as our equation is concerned.
Yeah, that makes sense. And so then here on the reactant side, it was being added into it.
So we were gaining that.
So it was gaining it.
So from the graph, it would have been the positive one.
Right. Okay, good call.
Okay.
So now what we can do is we can also talk about something called the enthalpy of formation, which is the amount of heat released or absorbed when a mole of a compound is formed from its elements.
Okay. So we probably should go over again what all our little symbols mean.
Okay.
So we have this little triangle is a delta. That means change in. So H is going to be your heat. Okay. So heat. So it's the change in your heat. And then you've got a little F there for the formation.
Right.
So it's your change in the heat of formation. Okay, so it's a value change, just so y'all understand what all those little symbols mean. Okay.
And generally, when we're using this, we're going to have these a table kind of like this one with the standard heat of formation. And so this tells us the amount of energy. Now we're looking back at the positives and the negatives. So if it's positive, that means energy was going in, it's endothermic. If it's negative, the energy was coming out, it's exothermic. And so that's how much energy is involved.
Okay. So it was how much energy it took to make that particular compound.
Yeah, and if you notice, we've got every single different compound has a different energy, a different heat of formation number.
Right, because it takes a different amount of energy to make each specific type of compound.
Right.
Makes
Now,
sense.
What's not on there are your free elements. So the elements that are by themselves.
Right.
Like the carbon in the equation, the carbon, and the oxygen. Those are free elements.
These are free elements. Okay, so even though that's O2, it's still a single element, therefore it's free, right?
Yeah.
Okay, and so down here we have our free elements are always equal to 0.
Right.
Because it doesn't take anything to make them.
They're already that way.
Yeah, they already come that way.
So
Makes sense.
If we're looking at this, if we wanted to say the heat of formation of CO2, we would want to look up carbon dioxide
in our little chart right here, and there it is.
Yeah. So the heat of formation for carbon dioxide is negative 393.5 kilojoules per mole.
Makes sense.
Okay.
Okay.
We can also use that with a formula. So we can calculate the heat of formation, or the total energy, by adding up the
Products and reactants.
products and reactants.
Okay.
And then once we take those numbers, we
Subtract them.
subtract them to get how much energy is either going in or coming out.
Right, for the whole reaction, right? So
Yeah.
that's the heat of reaction. Okay, makes sense. So we are given a kind of a little mini table just for what we need for this one. So I can basically almost plug these in, right?
Yeah.
So CaCO3 was negative 1208. I'm touching the screen. And then CaO, it says, is negative 635. And CO2 is negative 393.5. Okay?
Mm-hmm.
And so these are totally separate sides, though.
Right.
So I'm going to add these together because it's being added here, right?
Mm-hmm.
So on my reactant side, I have still negative 1208. And on my product side, I'm going to have negative 1028.5 if I actually add those together. Okay, big thing here is make sure that you actually catch those negatives. They do need to be put into your calculator. Okay, so if these are my products, and these were my reactants, and again, don't forget which side is product and reactants. That's kind of a big deal because as far as our formula is concerned, I need to put them in backwards. Okay, so it needs to be negative 1208 minus, oh, see, I wrote it backwards too. My bad. Okay, so it needs to be products minus reactants, and our products were, oh, I changed my color. Negative 1028.5 minus my reactants, which were negative 1208. And
So
again,
we still have to make sure that we put in the negative.
yes, you
Okay.
really need to make sure you put in that negative. So this is minus a negative value, okay? If you're good enough, you can remember that if you're subtracting a negative, it's like adding a positive. But if we're not good enough to do that, then please don't. Just don't try. Just subtract the negative.
I'll just subtract the negative.
Yeah.
We've got this negative. We got this little negative button down here.
Yes, it's a
anyway,
really
so-
nice little negative. It's not a subtract, guys. It's a subtract and then the negative button, okay? And so our total was 179.5, and that is a positive value. So our total heat of the reaction, which is HRXN, was a positive value.
So that means the reaction would be endothermic.
Right.
Okay.
So this was endo, and this energy would have been on this side here being added into the equation.
So we would see 179.5 kJ plus CaCO3, so on and so forth.
Exactly. It would
Awesome.
be on your reactant side because it is positive and endothermic.
Okay. All right. I think I'm. All right. Let's do this next one then.
Okay, so CH4, plug it in, negative 75, okay, plus two O2s. Oh no, there's no O2 written down.
But O2 is by itself. It's a free element.
Right.
And it has to be 0.
Okay, so it's 0. All right, and then on my other side I have CO2.
Now
so
we do have.
negative 393.5. And then I have 2 waters, and I know water is negative 242. But I have 2 waters. Does that make a difference?
Do we have to multiply the two Do we have to multiply that number by 2?
Well, I've got 2 of them, so that would make sense to me.
Okay, so if I've got the coefficient there with the 2, so I need to multiply my heat of formation by
2.
that number.
Okay, that makes sense. And we didn't worry about it over here on the 2 O2s because that was 0, and 2 times 0 is
that makes
still
sense,
0. Okay, so add these up. So negative 75 plus 0 is negative 75. For my reactant, my products are negative 242 times 2, and then add negative 393.5. And again, remember to actually put your negative values in, and it is actually equaling 90.5. So products minus reactants, products were 90.5 minus negative 75. Okay, so we're going to have 165.5 for our heat of formation. Again, that is a positive value. So that means that this was endothermic, and it went in. Okay.
Okay.
Not too bad.
All right, so let's take a shot at the guided practice then. If you're having trouble or you want to follow along, go ahead and start up the guided practice video, which is right after this one.
Yep.
Alrighty.